Laplace transform of elementary functions. In the previous video, we have mentioned that the Laplace transform can be written in the form of integral here. With any given functions, its Laplace transform will be the solutions of these integrations. Let us look into a few common examples. Taking ft here equals to 1. Substituting this 1 into the formulas of the Laplace transform, you will get this. Integrating this, you will get this. The boundary conditions range from 0 to infinity. Substitute the upper boundary to be minus with the lower boundary. It is noted that e power of infinity will be equals to 0, while e powers of 0 will be equals to 1. Substitute the relevant value into the functions. You will be able to obtain the final solutions. In this case, Laplace transform of 1 will give you 1 per s. Let's say now your ft is equals to a constant k. Based on the principles that the constant can be brought out of the Laplace transform, Laplace transform of k will be equals to k Laplace transform of 1. Based on the previous calculation here, you know that Laplace transform of 1 will be equals to 1 per s, which will give you k times 1 per s, which eventually give you k per s. Let's say now the ft is equals to e power of at. Laplace transform of e power of at, it will be the integrations of this, where e power of at is substituted into the formula. In this, after combinations, it will give you this. Integrating the function here, you will get this, and solving the integrations, you will get your final solution here. Next, if we take ft equals to cos at, Laplace transform of this will give you this outcome when you substitute the ft into the formula. Integrating it and solve the integrations, your final outcome will become this. Let's say now we use t equals to ft. Laplace transform of t will be equals to this when you substitute t into the functions of ft. Integrating it and solve the Laplace transform, your outcome will be this. What you are seeing here is when this ft is substituted by some common function, you will obtain the outcome of the Laplace transform. Laplace transform of cos at will give you this. Laplace transform of t will give you this. Solving the common functions in the Laplace transform by substituting ft here, you will obtain a list of the output of the Laplace transform. These two tables will serve as the formulas for the Laplace transform of elementary functions. And these formulas are normally given in the reference of mathematics. You may refer to the table in order for you to solve the Laplace transform without going through a tedious process of integrating the functions. With that, from here on, when we want to solve the Laplace transform, we will use the formulas given in the table.